We're on problem 39. And it says, which ordered pair is the vertex of f of x is equal to x squared plus 6x plus 5? Now, finding vertexes of parabolas, there's a formula, and negative b over 2a, but you might forget that when you turn 30 years old. And the whole goal of this isn't just to pass an algebra exam, is to learn algebra. And then when you learn calculus, you'll learn actually a much easier way to figure out minimum and maximum points. But there's actually an intuitive way of doing it in algebra as well. What we have to do is just write this in that form where we have it. Let's see, we could write it in, if we could write this function, if we could write it in the form like this, f of x is equal to a times x plus or minus something, I don't know, b squared plus c. Then we know the vertex happens when x is equal to b, right? Because if you look at this form of a parabola, and you can write any of these in this form, then you say, okay, this term right here is always going to be positive. So the minimum point of this parabola is when this term is equal to 0. And then the minimum point of this term happens when x is equal to b, when this term is equal to 0. Right? And so the vertex becomes xb comma c. So let's do that with this. And you could memorize it. I mean, it ends up being minus b over 2a, but let's just actually solve it because I want you to have the intuition. F of x is equal to x squared plus 6x plus 5. And I wrote a gap there for a reason because we're essentially going to complete a square. We want to turn this x squared plus 6x plus something into a perfect square. And you've hopefully have some practice completing the square. What number is half of 6? Because when we square it, if we do x plus a squared, that equals what? X squared plus 2ax plus a squared. So if we map that to that, x squared is x squared, right? 2ax is equal to 6. So a would be equal to 3. And if a is equal to 3, a squared would be equal to 9. And you can't just add a 9 to one side of equation. You could either have to do it to both sides, or you have to do something to offset that. So if we added a 9 here, let's just subtract a 9 as well. Right? So then we get x squared plus 6x plus 9 plus 5 minus 9. So this right here, this part of it, that's equal to x plus 3 squared. And then this part, 5 minus 9 minus 4. And there, we got it into our format that we needed. So when does this function achieve a minimum point? Well, it achieves a minimum point when this part is equal to 0, or when x is equal to minus 3. And when x is equal to minus 3, this is 0, so f of x is going to be equal to minus 4. So that's the vertex, and that's choice A. And you could have done minus b over 2a. You'd get minus 12 over 2. Minus 6 over 2, which is minus 3. That's something you could memorize, but it's better, I think, to have the intuition. Problem 40. The graph of x over 2 squared minus y over 2 squared equals 1 is a hyperbola. And that makes sense. If this was, this is y over 3. X over 2 squared minus y over 3 squared is equal to 1. If this was a plus, we would have an ellipse. Fair enough. Which set of equations represents the asymptotes of the hyperbolous graph? And once again, there's some equations that people memorize, some formulas that people memorize, but you can actually have an intuition on this. So let's think about what happens as x approaches positive or negative infinity, because that's what we care about as an asymptote, right? What does the graph approach when we get to really, really large values of x, and it turns out really large values of y? So let's just rearrange this a little bit. Let's let's put y on the other side. So we get, and let's square this. So this is x squared over 4. Or let me keep it actually in that format. Let's keep that as x over 2 squared is equal to 1 plus y over 3 squared. Let's subtract 1 from both sides. So you get x over 2 squared minus 1 is equal to y over 3 squared. And now let's multiply both sides by 3 squared, right? Or let's multiply both sides by 9, right? Let's do that. Actually, let me just, to simplify this, let me rewrite this. I wanted to keep it in that form, but let me just, that's the same thing as x squared over 4 minus 1 is equal to y squared over 9. Multiply both sides by 9. And I'm going to switch the sides so we get y here. So you get y squared is equal to 9 over 4 x squared minus 9. All right, and that's about as far as we can get just with straight up algebra. But when we think about asymptotes, those are points that the graphs will never reach, but it'll get close to. So we have to think about what happens when x gets really large and correspondingly y gets really large. Well, as x gets really large, so as x approaches infinity, and you'll learn this in pre-calculus and calculus, these are limits, but it's really a very intuitive concept. As x gets really large, this minus 9 doesn't matter much. This term starts to dominate it, right? These terms matter a lot more than this minus 9. So as x approaches infinity, y squared is approximately equal to 9/4 x squared. And now we can take the square root of both sides of this, so you get y is approximately equal to plus or minus 3/2 x. And those are the actual asymptotes. Y equals 3/2 x, and y is equal to minus 3/2 x. And that's actually choice A. And, well, I won't go into the actual instruction of how you would think about graphing. Actually, why not? Why don't we just do that? We know what the asymptotes are. Let's actually think about how you would graph this. So if you were to draw the, it's all about learning, not just about assessing. If I were to, that's the x and y axis. And they tell us our asymptotes, 3/2 x and minus 3/2 x. So 3/2 x, that's the slope of 3/2 is 1.5. So it's a slope that would look something like, let me get the line tool out. So plus 3/2 x might look, x would look like that. So plus 3/2 x would look something like that. And minus 3/2 x would be something like that. And now we have to figure out, does this hyperbola go from there and there, or does it go from here and here? And there we just say, okay, does it have a, see, when y is equal to 0, right? When y is equal to 0, we get x over 2 is equal to plus or minus 1, right? X over 2 is equal to plus or minus 1. So you could say x squared, right? So you actually get x would be there. So x is plus or minus. So you know that this thing has x-intercepts. You can set y is equal to 0. You can't set x is equal to 0. If you get x is equal to 0, then you get minus, y squared is equal to some. So you get y squared equal to -1. You get some imaginary solution. So you know that it has x-intercepts, and you know that these are the asymptotes. So if you wanted to draw the graph, it would look something like that. I know that's not a great drawing, but hopefully it serves the purpose. But anyway, the choice was A, and hopefully you learned a little bit about asymptotes. Next problem. 41. Which of the following represents a hyperbola? Let me copy those. No, which of the following represents a parabola? They want to know. Oh, that's too small. I don't think you can see that. Get a bigger version of it. All right, that's a bigger version. There you go. Which of these represents a parabola? Well, we could just go one by one. This is a circle, right? That's a circle. Then you could graph it if you like. This is an ellipse, right? Where you just kind of weight the y's and the x squareds a little bit. This is an ellipse. If this was a negative, this would be a hyperbola. Ellipse. This one's a hyperbola because you have this negative here. Hyperbola. Now this one might not look like a traditional parabola, but it really is, right? Because if I were to divide both sides of this by 4p, I get x is equal to 1 over 4p times y squared. So it's a sideways parabola, right? It looks something like this. If that's the x and y axis, the graph will look something like this. It's going to be a sideways parabola, but it's a parabola nonetheless. So the choice is C. Choice is C. I think I have time for at least one more. Problem 42. They give the following equation. Let me paste it here. All right, and they say, what is the standard form of the equation of the conic section above. And essentially they want us to complete the square with the x's and the y's, so we get that, x minus something squared over some constant, plus or minus y minus something squared over some constant. So let's do that. So let's group the x and the y terms. So you get 4x squared minus 16x plus something, right? That's how we're going to complete the square. And then you get minus 5y squared. So let me just minus, and I'll do plus 5y squared. And then we have a minus here, so it becomes plus 30y. And then you have out here, you have a minus 9 is equal to 0. And just to simplify it, let's factor a 4 out of this part. So you get 4 times x squared minus 4x plus something minus, let's factor a 5 out, 5 times y squared plus 6y, probably plus something. Now let's add the 9 to both sides, is equal to 9. All right, so let's think about it. If we wanted to complete the square here, what do we put here to make this a perfect square? Well, if this was a plus 4, then this would be x minus 2 squared, right? So we're adding a 4 here, right? But we're really adding a 4 times a 4. We're really adding a 16 if you think about it. If I were to redistribute this, I just added 16, right? So if I add 16 to one side of the equation, I have to add 16 to the other side of the equation. So I'll add 16 there. And to make this a perfect square, let's see, half of 6 is 3, so 3 squared is 9. So if I had a 9 here, but I'm really adding a 5 times a 9, right? I could redistribute the 5. I really added a 45. If I do it to one side of the equation, I added a minus 5 times 9. No, I caught myself. I added a minus 5 times 9. So I'm really subtracting 45 from that side. So I have to subtract 45 from that side. And so this simplifies to 4 times x minus 2 squared, right? That's x minus 2 squared, minus 5 times, this is y plus 3 squared, is equal to, let's see, 9 plus 16 is 25, 25 minus 45. Let's see, have I made a mistake someplace? 25 minus 45. No, that's right. 25 minus 45 is minus 20. Right? And now we can divide both sides by minus 20, if I did this correctly. All right, we'll divide both sides by minus 20. And so you get x minus 2 squared. And what's 4 divided by minus 20? It's minus 1/5. Well, let me just do that. So 4 over minus 20 minus 5 times y plus 3 squared over minus 20 is equal to 1. And so this is equal to, let's see, this becomes a positive, and this one becomes a negative. So let's put this one first. So 5 over 20 is the same thing as y plus 3 squared over 4, right? That's this one. Plus, no, sorry, we have a minus. Minus, and this becomes 1/5, x minus 2 squared over 5. And that is equal to 1. And that, we haven't made a careless mistake, that is choice B. See you in the next